Hi all, welcome back to Cracking the FANG interviews. Today I'm going to be talking about the combination sub problem. This is Leetcode problem number 39, and the problem is popular at Apple, Google, Amazon, Netflix, amongst other top 10 tech company coding interviews. So let's dive into the problem first, understand it, and see how we can approach it. I really want to emphasize on the approach. And again, my method is not going to change. It's going to be things that we've already discussed in our previous videos. I want to sort of induce that thought process of how do you approach a unknown problem or the first time you see, this kind of a problem. So this is a snippet from Leetcode. I'll have a link to the problem in the description so you can try it out yourself. I'm going to focus on explaining the concepts and fundamentals. So the first thing you're given here is you're given a list of candidates and you're given a target, 7. And if you remember my previous problem, if you haven't already, I really encourage you to check out the subset sum problem that I've solved. This is going to be a direct application to that problem. I'll put a link to the problem in the description below. So if you know, I'm assuming you know what a subset is, but a quick summary for that is a subset of an array 1, 2, 3, 4 is any subarray that you can create with elements from the original, but they are in order. So you can only have 1 after 4, you can't have 4 comma 1. So this is correct, this is not. So this is the definition of a subset, right? And what you're asked to do here is you're asked to create, use these elements that are given to you, and you can actually repeat them. So you can have 2 comma 2 and maybe 6, for example, or 3. You're okay to repeat them to make these add up to this sum 7. So what you're doing is essentially, if I were to break what they're asking you to do, is you're given a target, which is also the total we saw in the subset sum problem we solved earlier. And they're asking you to use these elements and create a subset with repeating elements. So create a subset with repeating elements that sums to the given target. So in this example, it could be 2, 2 and 3, or it could be 7. Both of these sum to 7. Similarly, for this given candidates or array and a target of 8, you can just keep using 2 4 times to create 8. You can use 2 once and then use 3 twice, then use 3 and 5 together. So you're essentially creating, I want to really highlight this fact, subset with repeating elements. So if you haven't again already, I encourage you to pause the video, check out the subset sum problem, and then come back to this problem. It will make a lot more sense and make the concepts much more solid and clear. So I'm gonna solve another example to make sure the concept is clear. What we are doing in the subset sum problem is we were going from right to left, and we were going through each element, subtracting it from the total if it was less than the total, and also doing cases with and without. So we had this recursive tree, if you remember in the last example, and when the total hit 0, we'd return 1. So it would be one way, right? So in the subset problem, we were calculating the number of ways. Here we need the actual subsets, and with a caveat that the subsets can have repeated elements. That is the only change between these two problems. So the subset problem was number of ways. Here we need actual subset, but you can also repeat the elements in the subset. So there is a level of complexity here. So with this in mind, I'm gonna draw a direct analogy with the code and start diving right in. So there are two things we need to do. as the concept summary: one, create subsets, and two, store the subset. And there's one caveat when I say create subsets, and this becomes clear when you look at the examples given to you in the problem. Here the answer is 2, 2 and 3, but it cannot be 2, 3, 2. So what this means is the subsets have to be unique also. So the way we took this problem, we looked at examples, we sort of solved it, we looked at what is expected of us. We realized if we were to, just repeat elements, it wouldn't cut it, because, at that point, this could be a valid solution, but that's not the case. So you cannot have, you need unique subsets essentially. And again, this also violates the definition of a subset we discussed in the last video. They need to be ordered, meaning they need to follow the same order. For example, in this array 2, 3, 6, 7, a subset can be 2 and 6, but not 6, 2. So this would violate that property, because after you can first use 2 and then go to 3, but you cannot use 2, go to 3 and come back to 2, right? Because that's how they're ordered. So I'm gonna put a caveat here and call this create subsets and call it unique subsets, and then you store the subsets. Create repeated unique subsets, then you store the subsets. Let's look at the code. We first create this structure that's able to store all our solutions. As I said, here we are interested in the solutions themselves and not just number of ways. However, even if you store solutions and then calculate the length of solutions, it's going to tell you number of ways exactly. So they are sort of equivalent. That's why the subset sum problem is an important prerequisite for this problem. And this is the same base case as our previous problem. If the sum or total goes less than 0, we simply return. It's not really a way. But if sum is equals 0, we store the solution. In the subset sum problem, we were returning 1. But here we are actually interested in the solution, so we stored the solution. The next thing I do is very important. What we do essentially is we loop through each of the candidates, but with an index pointer. It's incorporated in the state. What this index is telling you is where are you at. So if you have this candidate array of 2, 2 and 3, and the 2, let me just make it 2 and 3, and you're at 2, what this index is going to help you with is keep exercising 2, and not go to 2, 3 and then come back to 2, which is not a valid subset, right? The example we discussed in the previous slide. So hold the thought. I'll explain this better with an example. What you do is you essentially take the solution you have so far, you append the candidate to it, and you also subtract that candidate value. This is very similar to what we did in subset, and you send the candidates back to the recursive stack. You can keep this as a global variable also. This is not really required, and you send this solution to underneath, so you can keep adding more to it. And you also send this index I, and I really want to emphasize on I and index to help you better understand the problem. So index and I. So I is nothing but index, right? It's the same variable. I think the better name for this it's equivalently starting from index going all the way to candidate. So what this means is, if you were to be solving an example to make the idea more concrete, and you have 2 and 3, your index, starting index, if we start our call stack from the right, I'm going to follow the same format as the subset sum problem. Start from here. This is index 0, index 1. Or you can also start from left to right. If you want, I can do that just for a change. we start at index 0. What we'll end up doing is we'll pick a candidate 2, subtract that from the total, which is, for example, 6. So you'll have 4 as your total. You've picked 2, and then you append 2 to as your solution, I'm assuming, and then you again make it 2 comma 2, and you make this update your total to 2, meaning you've picked another 2, and you keep exploring 2, right, as idx. So I is going to be 0, I is going to be 0, I is going to be 0, and here you'll have 2 2 2, and your total will be 0, and you'll end up in this case where you open. But if that's one solution, how about the other solutions? The way you'd figure that out is, again, you could have, for example, I'm just gonna make this up. If the total was 7, you could have 2 comma 2 comma 3. So you'd pick a 2 once, you'd pick a 2 once. I would allow you to check 0, then your I would become 1. So this is what this piece of code is doing. It's making sure you've exercised all your 2's first, and then you add the number 3. So this is a gatekeeper for order, as I like to call it. And again, if the idea is not 100% clear, I encourage you to draw the call stack, and this will really help you visualize what's happening, and why this works, and why this helps us keep the order and get unique repeated sub elements in the subset. Awesome. Thank you for watching yet another video from Cracking the Fang Interviews. I really hope you liked the video. Please like, share, comment in the description